In GeneXus, which players take part in modeling the design system of an application? Here we'll briefly describe them. After this course, you'll be able to learn more about them if you want to focus on the user interface of your application. Using a top-down approach, we have patterns, such as the work width of a transaction, which create web panel objects, among other things. These panels already include part of the design system. For example, actions have a common aesthetic, with a color that's also used in the buttons of the transaction, or web panel to display the information of an item. There's also a common header that all pages share by default. Not only those of the work with, but also those of the web panels we created from scratch. To avoid repeating this common header in all web panels, there's a master page object. Each web panel will be loaded inside the content placeholder control of its master page. And here's that header we were looking at. When the web panel is executed, its master page is also executed, and the page viewed in the browser is the combination of both layouts according to what the master page indicates. But there's also another way to compose panels. They are web component objects. That is, they're like small pieces of web panels that can be inserted into other web panels. For example, the work with pattern already did it. In the web panel showing a tourist attraction, we see 3 tabs. The first one showing the general information of the attraction. In GeneXus, for the General tab, we don't have attribute controls, but a control of component type. And in the events, it's indicated that a web component should be loaded in there. The one named Attraction General. We can see that it's of component type. If we open it, it looks like an ordinary web panel, with its parm rule and events. The pattern has already built its screens with these 3 objects in order to reuse as much as possible. We should also use them to create high-quality, cost-effective systems that can be implemented once and reused as many times as necessary. For example, suppose that now we're not interested in the back-office application that uses the pattern, but in the customer-facing one. In other words, the one that will be used by the end customers. Suppose that the designers of our team designed the first 3 screens of the application. The home, from which you call one that shows all the tourist attractions that can be visited. Also, from this one, by choosing an attraction, the last one is called, which shows the information of that chosen tourist attraction. Note that from a design point of view, there are repetitions. The 3 screens have a header with a background image, an overlay text, a menu, and a logo, and an image representing a chatbot. Ideally, a master page should be used to implement this common header, where, depending on the object being loaded in the content container, the background image and text will be displayed. This is programmed in the start event of the master page. If we need to reuse the logo and menu somewhere else, we can choose not to implement them directly in the master page itself, but in a web component, which we insert in the master page. And everywhere else we need it, of course. The web component has behavior. For example, we must program which object to call for each menu action. We also want to program an action when the user clicks on the logo. That's why it's not an object that allows reusing only one part of the screen, but rather it can be considered as a miniature web panel. For most purposes, it's a web panel. Okay. Let's go on. We didn't say it, but of course, the common footer should also be placed in the master page. The specific content of each page will be implemented in each individual web panel. These objects, web panel, master page, and web component, are executable. That is, they have behavior. But there's also another type of object that does offer to reuse only a piece of layout without behavior. It's called the stencil object, which allows doing the same thing that web components do, but only at screen level, so it will not have rules or events. It's a way to build more complex controls from simpler controls. If we look at the first two web panels, we see that this screen section has the same structure and design. In both web panels, we would have to repeat tables with text blocks and give them exactly the same layout. To avoid these repetitions, we can group these controls in a stencil object and then insert a stencil control in both web panels, which is loaded with the created stencil object. In general, if we know that the structure and design of a set of controls on a screen will be repeated on many screens, even if they have different content, then we can group them in a stencil object and use that object in the web panel, master page, or web component. The main difference between a web component and a stencil is that the stencil has no behavior. That is to say, it's not an executable object, while the web component is. This is why the stencil is clearly a design object. It's entirely intended for the design system. Another example of the use of stencils. We want to implement the menu with images that we see on the home page. There are 4 options with identical design. They're like cards. Then we could create a stencil and reuse it 4 times. In this stencil, we would have to overlay 2 texts and an arrow image on a background image in order to create this kind of card. That is to say, we're composing a kind of larger control using tables, images, variables, text blocks. And the question that we will answer in a moment is how we design all these controls. The other option, without using a stencil, is to directly incorporate a control made by a third party. For example, the control to design cards provided by the Semantic UI design framework. To do so, it's enough to create a user control object in GeneXus. Then, copy the HTML code provided by the supplier, change the fixed data to variable data, and indicate the file containing the style of the HTML elements, that is, the CSS file provided by the supplier. After doing this, we can use it as another control from the toolbox. And so at runtime, we will see, in short, first we talked about the patterns that use web panels, master page, web components to implement parts of the application. We've seen these objects as ways to componentize the programs for maximum reuse. Also, that they're objects with a layout and behavior. Now we're getting close to the heart of the matter. In any of these objects, we have a layout to be designed. And besides, being able to use third-party controls that already come with design, user controls, in that layout, we can use stencils to compose controls. But adding design to a stencil is the equivalent to adding design to any set of controls in a layout. So now we're getting to where we wanted. Regardless of where the GeneXus controls are located, how do we add design features to them? On the left is the screen as we want to see at runtime. On the right is the web panel home. It's loaded inside the displayed master page, which in turn uses the web component. In addition, besides having common controls, the web panel uses a stencil that also has a layout. The way to add design to each one of the controls of these layouts is using what we know as classes. Each control is associated with one or more classes, which determine how it's displayed on the screen. For example, if we look at the title get ready to explore, corresponding to the text block we see here, how do we set it to be a white title, to have that font family, and that size? The answer is by associating it with a class, which is named as we want and is semantically meaningful. For example, h1 negative to indicate headings on a dark background. Also, indicating the desired design features at the class level. The class can be reused in many other controls, and that's the advantage of its design features being independent of the control. So, the idea is to associate all UI controls or elements in the objects. For example, these 4 texts, with the style classes identified as significant. Then, it'll only be necessary to define the design properties of each of these classes in an object that centralizes them. Until GeneXus 17, this object was the theme, but from then on, it can also be its evolution, the design system object. Therefore, the page, which has class names for each control, will only need to know which design system object or theme it has to go to in order to retrieve the design properties of each one of those classes. And that's the way GeneXus separates the structure and content of the pages from their design. All of these objects that implement the page we will see in the browser have an associated style object, either the theme object or the new design system object. In this theme or design system object, the classes are declared with their specific properties that give them the style they will be displayed with on the screen. And this is how the controls are designed, through classes whose properties are defined in the theme or design system object. So far, we've only discussed how to develop web applications. However, almost the same will apply to native mobile applications or even Angular applications. At the time this video was made, the latest upgrade of GeneXus 17 was number 7. There, the default style object is still the theme, but in future upgrades, it'll be changed to the design system object. All of this will become a reality and fully come to life when Unanimo is released, a complete design system with a new design for the pattern and transactions too. There is a lot more to say and show, but here we simply wanted to present a complete overview of how the design system of any application is modeled in GeneXus, at this turning point when we're changing from the use of the theme object to the new design system object. There's already enough material in videos and wiki articles for you to learn more about all this whenever you want.